Okay, so continuing with question three. Question three is saying a hydraulic press contains 0.25 cubic meters of oil. Find the decrease in the volume of the oil when it's subjected to a pressure increase, which is equal to 1.6 times 10 to the power 7 pascals. The bulk modulus of the oil is equal to 5.0 times 10 to the power 9 pascals. A hydraulic press contains 0.25 cubic meters of oil. Find the decrease in the volume of the oil when it is subjected to a pressure increase of 1.6 times 10 to the power 7 pascals. The bulk modulus of the oil is 5.0 times 10 to the power 9 pascals. Okay, so this question is also coming from the first part we did, which we're looking at stress, strain, and elastic moduli. And this question is coming from that part of this topic, and it is asking us about something related to bulk modulus. So they've given us the initial volume of oil, V0, of which in this case I'm going to call V0, which is 0.25 cubic meters, like this. Then they've given us the increase in pressure, of which this we are going to call this delta P, which is equal to 1.6 times 10 to the power 7 pascals, like this. They've given us bulk modulus B of 5.0 times 10 to the power 9 pascals, like this. So what are they looking for in this question? They want us to find the decrease in the volume of the oil when it's subjected to this change in pressure, or that increase in pressure. So remember the formula of bulk modulus that we talked about? We said the bulk modulus is equal to what? B is equal to change in pressure over what? Over change in volume divided by the initial volume, V0. But since the change in pressure here, if the pressure is increasing, it is going to cause a decrease in the volume of the substance that we're talking about. Hence, we say this formula is balanced by a negative sign in front there, which means our final formula that we're going to have is going to be equal to what? It's going to be equal to B, which is bulk modulus, being equal to negative change in P, which is delta P, over change in volume divided by the initial volume, V0, like this. So what are we looking for? We're looking for the change in volume, of which we know in this case it is just going to be a decrease in volume. So what are we going to do? We're going to make the change in volume our subject of the formula. And if we do so, what are we going to have? We're going to have change in volume being equal to negative change in P divided by bulk modulus, and that being multiplied to what? Being multiplied to find our initial volume, like that. So I'm just going to plug what we've been given now. We just plug in whatever we've been given to say change in volume will be equal to change in pressure, of which they've told us to say this pressure is increasing. So negative change in pressure, which is 1.6 times 10 to the power 7, divided by the bulk modulus. They've given us the bulk modulus to say this is 5.0 times 10 to the power 9, like that. And we're multiplying this by the initial volume of the oil, of which the initial volume they've given us to say it's 0.25 cubic meters. And if I plug this into my calculator, I'm getting the change in volume, which is equal to negative 0.0008 cubic meters. Now, this negative is just trying to show that the direction of our change in volume is in a negative way, which means there is a decrease in from the initial volume that we've been given. For us to achieve or to land to our final volume, we are going to experience a decrease in volume of the oil, hence having a negative there. So our change in volume is negative 0.0008 cubic meters, of which this can just be written as 8.0 times 10 to the power minus 4 cubic meters, like this. So this is the actual change in volume on question 3. And the negative here is just trying to show that the direction of change is in the negative direction, which means we're experiencing a decrease in volume. Okay, so that is question 3. Let's move on to question 4. Question 4 is saying the 4 tires of an automobile are inflated to a gauge pressure of 200 kilopascals. Each tire has an area of 0.0240 square meters in contact with the ground. Determine the weight of the automobile. the four tires of an automobile are inflated to a gauge pressure of 200 kilopascals. Each tire has an area of 0.0240 square meters in contact with the ground. Determine the weight of the automobile. So using the data that we've been given, they want us to find the actual weight of our automobile. So I'm going to go to this page. This is question 4. And what data have we been given? They've given us the pressure in each tire, the gauge pressure in each tire. Say it is 200 kilopascals. But we know to say the SI unit for pressure is actually pascals. So we're supposed to convert this 200 kilopascals into pascals. And we're going to do so by multiplying this guy by 1,000, of which this is going to give us 200,000 pascals. Like this. Then they've given us the contact area of each tire. So I'll put the area, the contact area of each tire, they've given us to say it's 0.024 square meters like this. And then what is the number of tires we're having? It is equal to 4. So we're having the number of tires which is equal to 4, which means if we are trying to find the summation of the areas of all the 4 tires, since these are the tires that are carrying the automobile, we are going to say this area multiplied by the number of tires, which is 4 in this case. But before we do that, let's first use or bring about the formula of pressure. We know to say pressure is equal to what? Pressure is equal to force per unit area, which means we're going to say this is equal to what? This is equal to force over area, like this. And we've been given pressure in our question. We've also been given area in our question. And what does that mean? That means we're supposed to calculate the force on each tire, or the force that each tire is exerting on the ground. So which means we're supposed to make this force the subject to the formula, which means this is going to be equal to what? This is going to be equal to F being equal to pressure multiplied by area, just like that. So we've already been told to say each tire is going to possess a force, since we've been given the contact area of each single tire. So since this is supported by 4 tires, we're going to notice that the force that the tires are exerting on the ground is going to be exactly equal to what? Being equal to the weight of the automobile. And since this is the case, we've been given to say 4 tires are supporting this automobile, which means we're going to multiply this singular force that each tire is exerting on the ground by 4, since we have a total number of tires which is equal to 4. So let's calculate the force per tire. Force per tire. This will be equal to pressure in each tire, which is 200,000 pascals, multiplied by the contact area of each tire, which will be equal to 0.024 square meters, like that. And if we multiply these guys, we're going to get a force which is equal to 4,800 newtons as the force on each tire. And since we're having 4 tires, we're going to say the total weight of the automobile will be equal to 4 multiplied by the force on each tire, force per tire, like that, which means I'm going to say 4 multiplied by 4,800 newtons, hence having our total weight of the automobile to be equal to 19,200 newtons, of which in scientific notation, this guy can also be written as 1.92 times 10 to the power 4 newtons. So this is the answer which is giving us the weight of the automobile. And when you reach that point, that means we've calculated the total weight of the automobile. Remember, the force on each, that is being possessed by the 4 tires on the ground is actually exactly equating to the weight of our automobile, since the tires are the ones that are supporting the automobile. So which means the total force, or the summation of the forces, is going to give us the final weight of the automobile. And that is actually summing up question 4. Let's look at the next question, which in this case is question 5. Question 5 is saying in a hydraulic lift, the force applied on the smaller cylinder of area A1 is 3F1. If the area of the larger cylinder is 2A1, the maximum weight that can be lifted is dash. In a hydraulic lift, the force applied on the small cylinder of area A1 is 3F1. If the area of the larger cylinder is 2A1, the maximum weight that can be lifted is dash. So this question is actually directly relating to the topic that we covered in our second class, of which it's talking about the Pascal's principle. And we discussed what the Pascal's principle states. So this is question 5. But before we do anything, first let's calculate let's bring about the data that we've been given. So they've told us the area of the larger piston, to be equal to what? Well, let me put A capital L of large piston to be equal to what? To be equal to 2A1. They've also given us the area of a smaller cylinder to be equal to what? To be equal to A1. And they've given us the force on the smaller cylinder to be equal to what? To be equal to 3F1. And they've asked us to find the maximum weight that can be lifted. So this is a hydraulic lift. And what we're supposed to know is that a hydraulic lift works based on what we call the Pascal's principle. And we already talked about the Pascal's principle to say, it states to say that when you apply pressure on one end of a piston, that same pressure is going to be transmitted undiminishingly to the other side of the cylinder. So which means the pressure that is going to be applied on the smaller cylinder is the exact pressure that we're expecting to be at the larger cylinder. And what equation are we or is going to simplify that for us? We're going to say pressure at point 1 would be equal to what? Would be equal to pressure at point 2. That is the Pascal's principle. And this pressure, not to say pressure is equal to what? Pressure is equal to force over area. So which means force 1 divided by area 1. This should be equal to what? This should be equal to force 2 divided by what? Divided by area 2, like that. And they've already given us some of the data in this guy, because they've just told us to say so I'll say this is pressure on the smaller cylinder on my initial equation. I'll say this is pressure on the smaller cylinder and this is pressure on the larger cylinder. So they've given us the force that is on the smaller cylinder. They've already given, say this is equal to what? This is equal to 3F1. And I'm going to substitute exactly the way they've given us to say this is 3F1. And they've given us also the area of the smaller cylinder to say this is A1. And this is equal to what? The force on the larger cylinder. So the force on the larger cylinder, they haven't given us. And it is happening that this is exactly what is given us, the force that can be lifted with this hydraulic lift. So I'll say F2 or FL here, which is force on the larger cylinder, over the area on the larger cylinder. Did they give us the area on the larger cylinder? Oh, yes, they said this is 2A1, like this. I hope we are following. So if this is what they've given us, now what are we going to do? We're trying to find this guy. So we're going to cross multiply, and we're going to notice that we're remaining with FL multiplied by A1 being equal to 3F1 multiplied by 2A1. So I'm dividing both sides by A1, even this side by A1, so that I remain with the force on the larger cylinder on the other side. So I'm going to say this is equal to 3 multiplied by 2. This is giving me 6. So it's the same as I'm having 6 F1 A1 as my numerator divided by A1 here, of which A1 is a denominator. It can cancel out with the A1 that is on top. That means the maximum force that can be lifted by the hydraulic lift, which is applying on the larger cylinder, is going to be equal to what? It's going to be equal to 6 F1. This is what we are remaining with. And this is giving us exactly what we are looking for in question 5. So we're just we've just simplified Pascal's principle so that it is able to help us calculate the weight that this hydraulic lift can actually manage to lift, because hydraulic lifts work based on the Pascal's principle. Okay, so that is our question 5. Let's move on to the next question, which is our question 6. Question 6 is saying calculate the absolute pressure at an ocean depth of 1,000 meters. Assume the density of the seawater is 1024 kilograms per cubic meter and that the air above exerts a pressure of 101.3 kilopascals. So we're supposed to calculate the absolute pressure, and we've also already discussed this. They've already given us the depth here. They've already given us the density of the water, and they've also given us the atmospheric pressure, of which in this case they refer to it as the pressure that the air is exerting above the sea. The pressure that the air is exerting above the sea level, which is just simplifying, or it's another way of explaining to us about atmospheric pressure. So that is question A. And question B is saying at this depth, what force must the frame around a circular submarine porthole having a diameter of 30.0 centimeters exert to counterbalance the force exerted by the water? Okay, so that is question 6, having two parts, part A and part B. Let's go to our blank board. This is question 6. Question 6A, and question 6A is just wanting us to calculate absolute pressure. So what data have we been given? We've been given to say we have depth, which we refer to it as H, or height of 1,000 meters. We've been given density of seawater, so this is rho to represent density of seawater of 1024 kgs per cubic meter. And we've also been given atmospheric pressure, of which I'm going to represent it as rho initial, which is equal to what? Which is equal to 101,000 pascals. So I've converted the 101.3 kilopascals that they gave us in the question to 101,300 pascals, because I'm expected to use the SI units of pressure. Okay, so I'm going to use this to find the absolute pressure that is being experienced here. And we know to say the formula for absolute pressure is equal to P, or rho initial, which is atmospheric pressure, plus gauge pressure, of which we know to say the formula for gauge pressure will be equal to rho of the material that we are dealing with, or of the fluid that we are dealing with, multiplied by G, which is the acceleration due to gravity, multiplied by the H, which is the depth inside the fluid that we are discussing. So this is going to be equal to what? This is going to be equal to the atmospheric pressure, which is 101,300 pascals, plus the gauge pressure that we've been given. So what is the gauge pressure that we've been given? Or rather the density. The density, I don't know why I was referring to the pressure as rho. The density is our rho. So the density that we've been given is 1024, like that, multiplied by the gravity, which we know to say gravity is equal to what? Gravity is equal to 9.81 multiplied by the height, or the depth in the fluid, which is 1,000 or 1,000 meters. So if I punch these into my calculator, I'm supposed to find an absolute pressure, which is actually equal to 149, 740 pascals. So this is the absolute pressure that we are having. Or if I write it into scientific notation, I'm going to have 1.01 times 10 to the power 7 pascals. Like this. So this is the answer that we're expected to find as absolute pressure on question 6A. Now let's look at question 6B. I'll wrap this part. Let's look at question 6B. So question 6B is asking to say, at this depth, what force must the frame around a circular submarine porthole having a diameter of 30.0 centimeters exert to counterbalance the force exerted by the water. So what are we going to do? We've been given diameter of the porthole that they're talking about, and they've told us to say this diameter is actually secular in nature. This diameter is having 30 centimeters as diameter, of which if we convert this into meters, we're going to get 0.3 meters of diameter. So one thing that we're also supposed to do, we're supposed to find the area of the diameter that we're talking about. And since they've told us to say this, the porthole is secular in nature, you know, to say area of this secular diameter is going to be equal to what? It's going to be equal to pi r squared, like this. And this r is just going to be half the diameter that we've been given. So I'm going to say this is equal to what? This is the area. This will be equal to pi multiplied by 0.3 over 2. This is the radius, and a squared outside there. And I'm going to find my area as equal to 0.0707 square meters. So this is the area of the porthole that they're talking about. So let's now calculate the force that this porthole is exerting due to the water that they've talked about. And we know to say the formula to calculate force is equal to what? It's equal to pressure over area of which this pressure here is gauge pressure. Since atmospheric pressure is inside this circular submarine, the gauge pressure is the one which will be responsible for exerting a pressure outside of the submarine. So the pressure that we are using here is strictly the gauge pressure and not the absolute pressure or the atmospheric pressure. The atmospheric pressure is inside. It is the one which is responsible for the comfort of the divers that are inside the submarine, because the pressure inside isn't supposed to change, because people might die if the pressure increases inside the submarine. So inside they're going to maintain the atmospheric pressure, but what happens outside the submarine, you're going to notice that there will be gauge pressure that will be the one imposing a force on this circular porthole that we're talking about on the submarine. So notice the pressure is equal to force over area, and if we are looking for specifically force, we're going to equate that to pressure over area, of which I've told you to say the pressure that we'll be talking about here is actually the gauge pressure. So we've already calculated the force here. I mean, we've already calculated the gauge pressure, and all we are going to do will be equal to what? We're going to say this is equal to what for force? Sorry, let me do this. I'm going to say pressure is equal to force over area. This means what? This means force is equal to pressure multiplied by area. Okay, so this is the correct formula. I'd written to say force is equal to pressure over area, which wasn't making any sense. So we're going to get the pressure, say 10, 0.48, 440 multiplied by the area of the circular porthole, which is 0.0707. So the pressure that I've used here is the gauge pressure. I can tell to say there is a slight difference with the one that is here, because this one is actually absolute pressure, whilst here I'm only using gauge pressure. And I've given you the formula for gauge pressure to be this guy here. Okay, so if I punch this into my calculator, I'm getting a final area or a final force on the porthole to be equal to 7.09 times 10 to the power 5 newtons, like this. So if I round it off, I'm getting this number, but on the calculator it's showing a bit something different. But if I round it off the nearest significant figures, or to 2 decimal places, I'm actually getting that guy as my final answer. I'm getting 7.09 times 10 to the power 5 as my my force being exerted on the porthole. Okay, so let me just change this. Realized it's giving me 7.07 times 10 to the power 5 newtons as the pressure that is being exerted on the porthole. Okay, so that means we've calculated the force that is being exerted on the porthole using provided the diameter that they gave us and the the gauge pressure that we've calculated. Remember, calculate the force, we're going to have to calculate the area first. And we've calculated the area, then we've multiplied the area to the gauge pressure to find the actual force that is being exerted on